Welcome to the TVE Happy Math Hour, our weekly interactive math reviews for Math 1314 and Math 1324, presented by Ms. Yvette Chuca, Mr. Ruben Carizales, and Mr. Albert Isasi. Our session will be starting soon. The session will be recorded so that you can come back to it later if you need to, and so others who may have missed out on today's events will be able to watch it. So now at this time, please make sure you mute your mics for best sound experience. Otherwise, the feedback could interfere with information we will be sharing today. We will be sending the Math 1324 room link in the chat so that you can connect to your session if you're here for Math 1324. We're not doing any sign-in sheets this semester. Instead, we are logging students in through MyScio. So during the presentations, Ms. Patricia will be reaching out to each of you for your EPCC ID number and instructor's name to make sure you receive the credit for being here today. Please be sure to respond to her so she can sign you in. Without further ado, I will pass it on to our presenters so that we can begin. Thank you.
Thank you, Ms. Truman. Mr. Carizales will be going to the Math 1324 room. So if you're here for that, they placed the chat. In the chat, you'll see the link. And so for 1314, we'll get started with basic matrix operations and using matrix operations. Okay, so first we'll look at some topics from section 8.1. And so we want to know what is a matrix. So a matrix is just a rectangular array of numbers. And so we have all these numbers in here. And it can be in any size. So it could be matrix, it could be smaller matrix. The numbers inside, we call them elements. And so one of the things that we're going to be looking at is how many rows and how many columns does a matrix have, and that's going to give us the size of the matrix. And so if we look at this example, going down is your columns, going across is your rows, okay? And if you notice here, for example, it says A subscript 1, 1. The subscripts actually tell you the location of that number. So the first number 1 is the row, and then the second number is the column. So if we look at this example, the first number is 3. That tells you that you're located in row 3. And the second number is 2. That tells you you're located in column 2. Okay, so the size of the matrix is given by the number of rows and the number of columns. So if we look at this matrix, we have 1, 2 rows and 2 columns. So we say that the size or also the order. So let me put that in the chat because sometimes I say it incorrectly. But so if you see the word size or if you see the word order, then that's just telling the same thing. So in this case, it's a 2 by 2 and it has a special name. We call this a square matrix because it has the same and the same number of columns. This matrix is called a row matrix because it only has 1 row and it has 2 columns. And this one here is a column matrix. If you notice, it has 1 column and 2 rows. And then this matrix is a square matrix, but it also has a special name called the identity matrix. And the reason it's called the identity matrix is because in the diagonal, it's all ones, and everywhere else it's going to be a 0. Okay, so let's look at some more examples. I'm going to give you a second or 2 or 3 seconds so that you can see if you can match these sizes with these matrices. Okay, and in the meantime, I'm going to get my pencil out. For the first one, number 2. So what size is that? And so if you were thinking that it's a 1 by 1, then that is correct. And then the second one, notice that we have 4 rows. So here we have 4 rows, 1, I'm sorry, 1 row and 4 columns. So this is 1 column, 2 columns, 3 columns, 4 columns. So this is going to be a 1 by 4. So that would be letter C. And then this next matrix is full of zeros. We call it the zero matrix, but it has 1, 2 rows and 2 columns. So that's going to be letter B. And then the last one, we have 3 rows and 2 columns. And that's going to be letter D. Okay, so let's continue. So one of the things that we want to do is we want to take a system. Remember, we did these in chapter 7, and we're going to be writing the system as an augmented matrix. So the augmented matrix, on the left side of the matrix, you're going to write the coefficients, and on the right side, you're going to write the constants from the system. So here we have 3x, so we wrote the 3. We have a 5y, so the 5 is your coefficient, and then we have a -9, which is your constant. Then we have a 1, a 4, and a -10. Okay, so this is called the augmented matrix. So let's look at this example. So we want to write the augmented matrix. So we have our system here. So again, on the left side, we're going to put our coefficients. On the right side, our constants. And the size, so another word is the size, the order, or sometimes they're going to ask for the dimension. So if you see those 3 terms, they all mean the same thing. Basically, how many rows and how many columns. Okay, so for this example, my coefficients for my first equation is 1, 3, and -1. So I have 1 for my x, 3 for my y, but I don't have a z, so I need to make it a 0. And then I have my w, which is -1, and my constant, which is 9. Then we go to the next equation. Notice that there's no x, so we use a 0 for the coefficient. Y is -1, z is 4, and w is 2, and then we have -2. And so in the same way, we fill in the last 2 rows here. Okay, so the reason we're going to be writing these into these matrices is we want to make sure that we can solve the system. So in chapter 7, we use the substitution method, we use the elimination method, and even the graphing method. So here, using matrices, we're going to learn new ways to solve these systems. Okay. So it says write the system of linear equations represented by the augmented matrix. So now they're giving us this matrix and we want to find the equations. So here we're going to have the system. The matrix is 6, 5, 2. Then we have 3, -9, 0. So the equations are going to be 6x, 5y, and 2. And then the next row is 3, -9, and 0. So the equation is going to be 3x minus 9, and then we have 0. Okay, so here's another one. Write the system of linear equations. And so here we have a 1, so that represents x. The 0 is for y. And then we have the 4 is the last number. So in most cases, let me get my pencil here. You will see this vertical line, but sometimes it's not there, especially if you use a calculator, you're not going to see that line. But here we're going to go ahead and see it. So if we go ahead and click, then I can see here that x is equal to 4 and y is equal to 3. Okay, so this is very special because on the left side here, if we have the identity part, so where it's all ones and zeros, then we can easily find those solutions for x and y. So in doing these matrices, we have some operations that we're going to be able to use so that we can solve for these systems. One operation is to interchange rows. So you can switch the rows, any of the rows that you want. And the symbol for that is going to be this double arrow. Okay. We can also multiply a row by any non-zero constant. So you can multiply by any non-zero constant, and the symbol we use is C represents that non-zero number times that row. We can add multiple rows together. So we can add row 1 plus row 2, and we're going to use these operations. Okay. But what is our goal? So this is the process that we're going to use. You're going to have a system just like this, and we're going to write it as an augmented matrix. Okay. Once we have the augmented matrix, we're going to use these row operations so that we can make this matrix look like the one on this side. And we call this a row reduced echelon form, where we have ones in the diagonal and 0 everywhere else. Okay, so the big goal is to take the system, write it into a matrix, and then reduce that matrix to this form. Okay, so let's practice with these row operations. So it says interchange the first and second rows. So all we have to do here is switch the rows. So this is the original matrix. When you switch the rows, now we just get -2, -1, 2, 0, and 3, 0, 1, 3, 4. So you can see the switch of row 1 and row 2. Multiply by the first row by the original matrix by a half. So the first row is here, and they want us to multiply it by a half. So 1/2 times 2 is going to give us a 1. Okay, so they want us to multiply 1/2 times 2. And, oops, sorry, let me go back. Okay, so 1/2 times 2 is going to give us the 1 over here. Let me just circle it. Okay, and then 1/2 times -4 is going to give us this -2. 1/2 times 6 gives us a 3, and 1/2 times -2 gives us that -1. Okay, so that's all that means. This is the symbol for it. So it's 1/2 times row 1, and then the arrow says to put your answer back in row 1. Okay, so let me go ahead and go to the next slide. The third one, it says add -2 times the first row of the original matrix to the third row. Okay, so what they want us to do is multiply -2 to row 1, and then whatever we get, we want to add it to row 3. Okay, so here is my row 1. So if I multiply -2 times 1, I get a -2. And if I add it to the third row, which is 2, then I get 0. So I place my 0 here. And then we have -2. Let me get the pencil out again. Okay, so we're multiplying -2 times 2, and whatever you get there, you're going to add it to this one. So -2 times 2 is -4, plus 1 is going to give us a -3. So we place our answer in row 3. Then we go to the next one. So the next one is -2 times -4 is +8, and then we add it to the 5, so we get 13. And then the last one is -2 times 3 is -6. We add it to the -2, so we get -8. Okay, so we're going to be using these operations, and again, we'll do some examples in the next slide. Okay, so here is a matrix. It says solve the system using matrices. So here's your system. So the first thing you want to do is write the system as an augmented matrix. So we have 2, 4, 8, 2, 4, 8. Then we have 1, -1, and 5. Then we're going to use our row operations, and this is going to be our goal. Okay. So if you notice here, And let me write the go on the top corner. That way we can always see it. Okay, so remember our go is going to be to have 1, 0, 0, 1. And then we're going to get some numbers on this side. Okay, hold on. Okay, so then we're going to have some numbers on the right side. All right, so here our goal is to find a 1 or to have a 1 here. So I have a number 2. So there's two ways you can make that a 1. The first way is you can multiply the 2 by a half, and that's going to become a 1. And then you can multiply 4 by a half and 8 by a half. But if you notice here, I already have a 1 down here. So what I can do is just switch the rows. So I'm going to go ahead and do that. So I'm going to switch row 1 with row 2. And so my new matrix is 1, -1, and 5, 2, 4, and 8. Okay. So by me switching the rows, this matrix here and this one here are equivalent. Okay. I'm not changing the matrix. I'm just using the operations to get something that is equivalent. So now I have a 1, which is what I want in my goal. So the next step is anything below that 1, I want it to be 0. Okay. And I recommend that you stay in this process to avoid any if you go and change this diagonal 1, it might change these numbers again. So by making this first number a 1, anything below it a 0, it's going to save you some time and maybe some frustration. Okay, so here I have a 1. Now I need to make this 2 a 0. Well, in order to make the 2 a 0, I need to add to this matrix, I need to add row 1 plus row 2. But in order for me to cancel, I have to have the same coefficient. So if you remember when we were looking in chapter 7, if we had something like this, let me get the pencil. So remember in chapter 7, we had like x minus y is equal to 5. And then here we had 2x plus 4y is equal to 8. And if you wanted to eliminate the x's, then what did we do? We multiplied the first row. My pencil went away. We multiplied this by a -2. And then what did I do? So -2 times x was -2x, and then we added to the 2x, so that gave us a 0 here. So we're going to do the same thing with these matrices. It's the same idea. And so here, I'm going to go ahead and multiply the first row by a -2, and then I'm going to add it to the second row, and whatever answer we get, I'm going to put it in the second row. Okay, so notice here the first row, we don't want to change it, so I just wrote it the way it is. But now I can do the work. So I have -2 times 1 is -2 plus 2 gives me a 0. Okay, and then we have to keep multiplying. -2 times -1 is +2 plus 4 gives me a 6. And then I go all the way across. So -2 times 5 is -10 plus 8 is -2. So now our goal was to have a 1 here and everything below it a 0. So now we can go to the next diagonal, this 6. I want to make this 6 a 1. So in order to make this 6 a 1, I can multiply by 1 6. Okay, so I'm going to multiply 1 6 times row 2, and whatever answer I get, I'm going to place it back in row 2. So the first row, I'm not going to do anything to it, right? So this 1 6 times 0, 1 6 times 6, 1 6 times -2. And so that's going to give us 1 6 times 0 is 0. 1 6 times 6 is 1. 1 6 times -2 is -1/3. My first row, I left it the way it was. Okay. So now that I have a 1 here, I need to use this one to make everything above it a 0. Well, notice here I have a -1 and a 1, so I can just add the two rows, row 2 plus row 1. Since I'm trying to change the -1, my answer, I'm going to place it in row 1. Okay, so let's go ahead and add these. So we have 0 plus 1 is 1. 1 plus -1 is 0, so I put the 0 here. And -1/3 plus 5 is 14/3. Okay, so now notice on the left side, I have my identity matrix, all ones and everything 0. So this tells me that x, this is the one is for x, is equal to 14/3, and the y is equal to -1/3. Okay. This process that we're doing is called Gauss-Jordan elimination. And so let's try another example. So again, here's my go on the top, and I want to change this so that it looks like this one here. So -3 is not a 1, so I want to make it a 1. So anytime you want to make something a 1, you can multiply by its reciprocal. So I'm going to multiply that row by a -1/3 to row 1, and then my answer I'm going to put in row 1. Okay, so -1/3 times -3 is 1. -1/3 times 4 is -4/3, and -1/3 times 22 is -22/3. Okay, so now my second goal is to make anything below it a 0. So I need to make this 6 a 0. So if you want to make something a 0, then you multiply the first row by its opposite. So here's a 6. So I'm going to multiply the first row by a -6. Okay, so that's what I wrote here. So -6 times the row 1. Then I'm going to add it to row 2 and place my answer in row 2. And this should just be a straight arrow, not a double arrow. Okay, so let's go ahead and do that. All right, so the first row, I'm not going to change it, so I just write it down. Okay. And now we can do the work. So we have -6 times 1 is -6 plus 6 is 0. And then the next one, -6 times -4/3, that's going to be a positive 24/3, which is 8. And then plus a -4, so that gives me a positive 4. And then the third one, -6 times -22/3, and then plus -28. So here we get 44 minus 28, so we get 16. So now we have our 0 here. Now we need to make this 4 a 1. So again, remember, if you want to make this number a 1, you just multiply by its reciprocal. So we're going to multiply that equation by 1/4. So 1/4 times 0, 1/4 times 4, and 1/4 times 16. So again, if we do the work, 1/4 times 0 is 0, 1/4 times 4 is 1, and 1/4 times 16 is 4. So we're almost at our goal. Now we just need to make this become a 0. So again, if you want to make this a 0 and you have a 1 here, multiply this 1 by its opposite. So its opposite would be a positive 4/3, and then add the rows together. So we're going to multiply 4/3 times the second row, add it to the first row, and our answer we're going to place in our first row. The second row I'm not changing, so I just wrote it down. And so now we can start the process. So 4/3 times 0 plus 1 is 1. And 4/3 times 1 is 4/3 plus a -4/3 is 0. And 4/3 times 4 is 16/3 plus a -22/3. That gives us a -6/3, which is -2. So my solutions here are x is equal to -2 and y is equal to 4. So you might be thinking, why do I use this method if I like the chapter 7 substitution elimination method. So for these smaller systems, chapter 7 methods work beautifully. But if you have a bigger system, then matrices will help you to solve those. Of course, with technology, um, you would, if you had something like 4 equations, 4 variables, then you probably want to use technology. And in a little bit, I'll put a file, I'm sorry, not a file, a link to a video that I have that shows you how to do these on your calculators, or you can use an online calculator. But of course, if you're taking an exam, you might not be able to use that. So paper and pencil always works best. All right, so that was section 8.1. 8.2 actually is less complicated than 8.1. So in my classes, I actually cover 8.2 first, and then I go to 8.1. So for 8.2, we're going to see how do we add two matrices, how do we subtract two matrices, and how do we multiply. So in order to add two matrices, they have to have the same dimension. In other words, they have to have the same size. And if they do, then we add the corresponding entries. And the same goes for subtraction. And two matrices are going to be equal if they have the exact same numbers in each of the um, corresponding entries. Scalar multiplication is just multiplying a number times the matrix. And then subtraction, you have to have the same dimension and you subtract corresponding entries. Or if you want, you can change it to addition, okay, by doing this here. So let's look at these examples. So letter A is 3 times A. So 3 is called the scalar, and we just want to multiply it times A. So I always like to write it this way. So 3 times the matrix. And now basically what happens is you're going to multiply 3 to each of those elements in the matrix. Okay. So 3 times 2, 3 times 2, 3 times 4, and so on. So if we do the work, then we end up with 6, 6, 12. 3 times negative 3 is negative 9. 3 times 0 is 0. 3 times negative 1 is negative 3. Here we get 6, 3, and 6. Okay, and that's it. So that's for scalar multiplication. Letter B, they want us to multiply by a negative 1. So negative 1 is your scalar. So we're going to multiply everything in the matrix by negative 1. And so we end up with negative 2, 0, 0, negative 1, positive 4, negative 3, positive 1, negative 3, negative 2. Okay, so any questions on multiplying by a scalar? Okay, let's look at C. So we have 3a minus b. So first we can take care of the 3a, which we did, right? This is 3a. So I'm going to put it here. And then minus b is this matrix. And so if I want to do this, one thing I should check is that the order is the same since I'm trying to add these. This is 3 by 3, 3 by 3. So yes, we can add them together. So the way we add is we add each corresponding entry. So 6 plus negative 2 is 4. 6 plus 0 is 6. 12 plus 0 is 12. Negative 9 plus negative 1, negative 10. 0 plus 4 is 4. Negative 3 plus negative 3 is negative 6. And 6 plus 1 is 7. 3 plus negative 3 is 0. And 6 plus negative 2 is 4. Okay. Here's another example. So I like to put this picture here because one of the most common questions I get is if a student's trying to enter their answer, maybe they need a bigger system, or maybe, a bigger matrix, or maybe they don't need 3 columns. Maybe they just need 2 columns. And so to adjust your column, your matrix, you would use these arrows here. Okay, so if you press this green arrow, it's going to take away a row. If you press this one, it's going to add a row. And then the same here, or it's going to add a column, and these are what add the rows. Okay, So if you need to adjust your matrix, you click on these arrows and it's going to adjust it for you. So here we want to add A plus B. So one of the first things you want to ask yourself is, do they have the same dimension? Do they have the same order? And so we can check. And so here, if I'm trying to add A plus B, A is a 2 by 3 and B is a 2 by 2. So I cannot add those because they're not the same size. So my answer would be impossible. Okay, so let's go to the next problem here. Solve for X and Y. So the only thing we know about this is that this matrix is equal to this matrix. So if they're equal to each other, they have to have the same numbers in the same location. So for example, here I have a -4 and here I have a -4. So in this one, X has to be -3 so that they can be equal to each other. So my answer for X is just going to be -3. And then for this Y, I have a 21. And so that's going to be my answer, -3 and 21. So let's look at the next one. So here I have 18 and 18, 5 and 5, and then I have an X and a 2X plus 5. And then I have a 2 and a 2. So if I'm trying to solve for my X here, so I have X is equal to 2X plus 5. So here I have X is equal to 2X plus 5. So we just solve for X. Okay. So I'm going to subtract 2X and I get -X. And then divide by -1. So X is equal to -5. So this X is -5. And in the same way, then I have a 1 and a 1, a 2 and a 2. 16 is equal to 5y minus 4. So now I just need to solve for y. So I add 4 on both sides. So I get 20 is equal to 5y. Divide by 5, and I get 4. Okay, so here's another example. Solve for x in the equation. Okay, so I have x is equal to 2 times a. So this is my a. Plus 2 times b. This is my b. So first we'll take care of that multiplication. 2 times -3 is -6. 2 times 2 is 4. 2 times 3 is 6. -4. 2 times 0 is 0. 2 times 4 is 8. And then we do this the same way. So we end up with these two. We're trying to add these, so the order is 2 by 3 and 2 by 3, so that's good. We can add them. So -6 plus 6 is 0. 4 plus 4 is 8. 6 plus -10, -4. -4 plus 10 is 6. 0 plus 0 is 0. 8 plus 6, 14. Okay, so let me see. Okay, so here we have solve for x. So they give you this equation. So first we need to solve for x. I would recommend to do that first. So I'm going to go ahead and move the 2x to the left side by adding 2x on both sides. And then I'm going to subtract 4b on both sides. So I end up with 2x is equal to -2a minus 4b. Divide by 2 on both sides. So we get x is equal to -2 divided by 2 is -1. -4 divided by 2 is -2. So now that I have this equation, I can substitute my matrices in here. So I have x is equal to negative. So negative is just -1. And then A, that's my matrix A. And then here I'm going to go ahead and press or put addition. And then -2 is my scalar and the matrix B. So if we simplify, multiply that -1 into all of these elements or these numbers. So we end up with 2, -1, -1, 1, 0, and -4. And on this side, we're multiplying -2 times 0 is 0. -2 times 2 is -4, and so on. So now I can add these. 2 plus 0 is 2. -1 plus -4 is -5. -1 plus 4 is 3. 1 plus -6 is -5. 0 plus 0 is 0. -4 plus -6, -10. Okay, so multiplication. So to multiply two matrices, this is what we're going to be looking at. So in order to multiply matrix A times matrix B, you want to write down the size right here. So this is an m by n, and this is an n by p matrix. In order for us to multiply, we have to make sure that the number of columns of the first matrix is the same as the number of rows of the second matrix. In other words, these inside numbers have to be the same, okay? That's the only way that you can multiply. The outside numbers, the m and the p, that's going to tell you the size of your result after you multiply. So when you multiply a times b, that size is going to be these outside numbers, okay? So I'll start with some small matrices here. So we have 4, 1 and 1, 2. So first thing is to write down the order. So this has 1 row, 2 columns. This has 2 rows and 1 column. So notice that the number of columns is the same as the number of rows. In other words, these two numbers are the same. That means that yes, we can multiply. The outside number is going to be how big your matrix is when you multiply. So that means we're going to have a 1 by 1 answer. So how do we multiply? So what you want to do is you want to take this first row and multiply it times the first column. So we're going to multiply the first number 4 times the first number in this column. So 4 times 1 is 4. And then we multiply the 1 times the 2. So this right here, 4 plus 2, that's going to be your answer, 6. Okay. So it's going to be this row times this column, the first number with the first number, second number with the second number, and then you add the results. So we get 6. Okay, so let's try the next one. This is a 2 by 1. This is a 1 by 1. So these inside numbers are the same, and your result is going to be a 2 by 2. Okay, so how are we going to multiply? I'm going to take this row by this column. So it's a 1 times 4, and then there's nothing else there. So I write my answer is going to be 4. And then we go with this row and the next column. So it's 1 times 1. So that's going to be your result on the next place. And you have no more columns. So now we can go to the next row. Okay, so now we're going to use this row times this column. So 2 times 4 is going to be our next entry here. And then we go to the last column. So 2 times 1 will be our last entry. And if we just multiply these out, we get 4, 1, 8, and 2. Okay. So let's try some more. Find a squared where a is 3, 1, negative 1, 2. So a squared is equal to a times a. So if we multiply these, check the order or the size, 2 by 2 and 2 by 2, that means that we can multiply since these red numbers I have here are the same. And my result are going to be a 2 by 2. Okay, so we're going to take this first row with the first column. So 3 times 3 plus 1 times negative 1. That's going to give you the first entry. And then we use the same row, but now with the second column. So 3 times 1 and 1 times 2. That's going to be your second entry here. There's no more columns, so we go to the next row. So it's this row with the column. So negative 1 times 3 and 2 times negative 1. So that's going to be here. And then go to the last column, negative 1 times 1 and 2 times 2. So if we simplify, 3 times 3 is 9. 1 times negative 1 is negative 1. and this is 3, that's 2. Negative 1 times 3 is negative 3, negative 2, and so on. So 9 plus negative 1 is 8, 3 plus 2 is 5, negative 3 plus negative 2 is negative 5, and negative 1 plus 4 is 3. So always remember it's the first row with the first column, then the first row with the second column, and if you had more columns, you would keep doing that. Once you have no more columns, you go to the next row, and then you start the process again. Okay, let's try this one. So here is my matrix B, here's my matrix A. I'm trying to multiply, but notice that the orders here are not the same. Okay, so we say impossible. Now we still have a few minutes, so if you give me a second, I can actually show you how to use the calculator. Let me just find it on my computer, and then I will share my screen. So if you have a graphing calculator, and if your instructor lets you use it, then this is the way that you would do it. Okay, just give me a second so I can find it really quick. Let's see. All right, cool. So let me share my screen with you all. And if you don't have a graphing calculator, it's okay. You can still check your answers, like if you use Desmos calculator, or there's another calculator, which I'll share the link to my video so that you can see how to use those. Okay, so let's see. Can you see my graphing calculator? Yes, okay. Okay, awesome. All right, so if you have a graphing calculator, then what you want to do is you would press second and then matrix, and it's going to bring up all your matrices, and then you go to edit. Okay, so I'm going to enter some stuff in here. Let's make it a 2 by 2, and then I'll just pick some numbers really quick. 4, 5, 3, and 2. And then I'm going to quit, and I'm going to do the same thing, but I'm going to enter numbers in the second matrix here, B. So we'll make this 2 by, I'll just make it 2 by 2 also, so that we can do some different things with it. So let's put it 0, negative 3, 5, and 6. And then I quit. So if you wanted to do some operations, let's say you want to add, so you would just call it and then press addition, and then you get the next one, B, press addition, and then it would tell you the answer. If you want to multiply, you would do the same. Just use multiplication. And then it does the work. But if you have a system, let me edit another one. Let's call this a 2 by 3. And notice here, if I had, let's say I had x plus 2y equals to 4. And then let's say I had 2x. So I'm just putting the coefficients, right? Oh no, let me go back to the calculator. Where's my calculator? Hold on. Oh, there it is. So let's say I had 2x, and then let's say I had 4y is equal to 20. So let's say that was the system, right? So remember we did the row operations with Gauss-Jordan elimination. So if we did that, we could do that here as well. Okay, so let me just get out of here. So if I go to second matrix, and I go to math, and I scroll all the way down, there's this button called RREF, that's row reduce echelon form. And if I click on it and I go get my matrix, which was C, and I press enter, then notice here it almost put it in row reduce echelon form. What happened here is my system has no solution because I have 0 is equal to 1. But so let me just change a number so that we can see it better. So let me change one of the numbers. Let's make it make this a 1. And hopefully that takes care of it. So if I do the same thing, so sometimes you will get that 0, 0. That just means that there was no solution. Okay. So second matrix, go to C. And if you notice here, we have the 1, 0, the 1, 0, and then you have negative 12 and 8. So if you are allowed to use your calculator, then you can use this here, right? But if you can use the calculator, at least you can use it to check your work when you're doing your assignments. Okay, so now let me give you the video for that calculator. Let's see. Let me go to my channel and get that video. If you go to this channel, there's a video lesson for each lesson in our textbook. But I have one for the calculator here. So let me graphing, no, calculator. So let me just get this and put it on the chat. But here you're gonna see you can use here's the matrices, and then on decimals it also, hold on, let me keep going. Okay, so let me put it in there for you in the chat. So this one will show you how to use the computer calculators to check your work, because when you take a test, if you're taking a test, you might not be able to use your calculator, or you might not be able to use a computer, but at least you can have these to check your work as you're doing your assignments. And as I mentioned, in this YouTube channel, there's a lecture for each section of 1314. So if you ever need to see a lesson, you can go there as well. But that was all that we had for today. So if you have any questions, feel free to ask us. There's still 12 minutes left. So we're almost down to the finish line. So probably in the next, after Thanksgiving, you'll be testing. So I will let Miss Truman let us know. Um, sure, give me a second. So I'll ask Miss Truman to share with us what is happening next week, or not next week, but I guess it's gonna be
Thank you, Ms. Chuka.
December 2nd.
Yes, I just posted the flyer up for December 2nd. Thank you all. We do want to remind you all about our previously recorded sessions, which are available on the YouTube playlist. I'll be posting that link shortly. Please join us next week, December 2nd at 11 o'clock. We're going to be covering the final exam review. And let me get that link for the previously recorded sessions for the YouTube playlist, which will be available later on today. There it goes. So also please know that the online tutoring is open now, and it is available through Blackboard Collaborate Ultra 7 days a week with our new hours for online tutoring, 12 p.m. to 9 p.m. Monday through Sunday, and face-to-face tutoring is also available Monday through Friday, 8 a.m. to 5 p.m. Thank you so much, Ms. Chuka, for presenting today, and thank you, audience, for coming by, and we'll hope to see you soon. Ms.
So
Chuka,
there was
go ahead, go ahead.
I'm looking for an example